You know, what if I told you there's this secret super date in the history of math? Just one single day on the calendar that somehow connects the very center of the Earth, the magic of your favorite animated movies, the safety of massive dams, and one of the most brilliant minds you've probably never even heard of.
Well, today we're going to pull back the curtain and make that hidden history of math a little easier to see.
The date is March 22nd. And yeah, it's one of the greatest dates in math history. Let me show you why.
On this one single day, separated by decades, sometimes even centuries, four incredible minds left a mark on the world that we still feel today. It's time to uncover their stories, one by one.
Okay, so let's start with a really big question. How in the world do we know what the Earth's core is made of? We've never been there, right? We can't just dig a hole that deep. And yet we've got these incredibly detailed maps of all its layers. How is that even possible?
Well, the answer takes us to March 22nd, 1953, and a German mathematician by the name of Gustav Herglotz.
See, Herglotz's stroke of genius was realizing that earthquakes are basically a giant ultrasound for our planet. He came up with this amazing mathematical method to listen to the seismic waves they create. By measuring how long it took for those waves to zip through the Earth, he could actually work backwards and figure out the density of everything they pass through. That's it. That's how we learned about the crust, the mantle, the core, all from right here on the surface.
When you really think about it, he literally gave us a way to listen to the Earth's heartbeat. And just like that, the first piece of our March 22nd puzzle snaps right into place. Now let's jump to a totally different world. Okay, next question for you. Have you ever been watching an animated movie or playing a video game and wondered how the characters bend and stretch so realistically? You know, when a character jumps or gets squashed, there's some seriously complex math going on behind the scenes to make it look right. So where did that math come from?
Believe it or not, the answer takes us all the way back to March 22nd, 1914, and to a French engineer and mathematician, François Cosserat, who did his best work alongside his brother, Eugene.
So the Cosserat brothers came up with this incredible theory of deformable bodies. Think about it like this. Before them, physics pretty much treated materials like a bag of sand, just a bunch of disconnected points. But the Cosserat said, wait a minute, no, materials are more like a box of tiny arrows. Every single point has a direction, an orientation. And that simple shift, that was the key to finally describing really complex movements like bending and twisting with math. The craziest part? Their theory was pretty much ignored for 50 years. But now it's the foundation for everything from CGI to modern engineering.
So what's the big takeaway for us? Simple. They wrote the hidden physics that makes all of our virtual worlds feel real.
All right, 2 down, 2 to go. Our March 22nd timeline is starting to fill up, and it's already connecting the core of the Earth to the virtual worlds right on our screens. So what could possibly be next? Let's think about a massive engineering project, something huge. How do you test if a 90-meter-tall dam is actually going to hold under all that insane pressure before you've poured a single drop of concrete? You can't just, build it and cross your fingers. This very problem brings us to March 22nd, 1926, and the birth of a Czech mathematician named Ivo Babuška. He actually faced this exact challenge when he was working on the Orlik Dam project. Babuška helped pioneer a technique called the finite element method. And honestly, it's such a brilliantly simple idea. Imagine you want to know if a really complex shaped cookie is going to break. Instead of trying to calculate the stress on the whole thing at once, what if you just broke it down into thousands of tiny, simple triangles? It's pretty easy to calculate the force on just one of those little triangles. Well, the finite element method does that on a massive scale for things like dams or airplane wings, testing millions of these tiny elements on a computer and then adding all the results together to see how the whole real-world object is going to behave. What he gave us really was a kind of mathematical crystal ball, a way to see the future of things that haven't even been built yet. 3 geniuses, 3 world-changing ideas, and they're all tied to March 22nd. We've got 1 slot left. In our final story, it isn't about the physical world, but about the absolutely limitless power of a single human mind. Let me ask you this. Do you think it's actually possible for one student to set an academic record so ridiculously high that it might just never be broken?
Well, the answer is yes, it actually happened. And it brings us to our final date, March 22nd, 1944, and the birth of an English mathematician, Margaret Millington.
Her time as an undergraduate at Durham University was, wow, it was legendary. To put it into perspective, she scored more than double the marks required for a top-tier degree. Her professor even said the record is unlikely to be surpassed. Just unbelievable. She went on to get her doctorate from Oxford, making huge contributions to a super complex field called modular forms. But, tragically, her brilliant career was cut short when she died from a brain tumor when she was only 28 years old.
Her story is just a powerful reminder that a mind can be so brilliant that even its brief light still illuminates a path for mathematicians working today. And there it is. Our timeline is complete. Just one date, March 22nd. Who knew it was this hidden thread connecting the deep secrets of our planet's core through Gustav Herglotz, the physics of our virtual worlds with François Cosserat, the safety of our biggest structures with Ivo Babuška, and a story of pure, breathtaking genius with Margaret Millington.
One date, so many breakthroughs. It just makes you wonder, doesn't it? What world-changing idea might be getting born right now, today?